In this journey tonight, we're going to talk about whether a technologically advanced civilization could have existed somewhere in the cosmos, or even on our planet before us. Not in the way ancient astronaut documentaries handle this question, with fuzzy logic and cherry-picked anomalies, but instead in the way actual scientists handle it, with geology, archaeology, physics, and the honest acknowledgement of what we know and what we don't. Before we get into it, if this is the kind of question you want a real answer to rather than a reassuring non-answer, take a second to like the video or subscribe. It helps this channel reach more curious people. Now let's actually think through this. Most people approach this question from one of two directions. Either they dismiss it immediately as conspiracy territory, not worth serious consideration, or they're convinced that ancient ruins prove some lost advanced culture that mainstream archaeology refuses to acknowledge. Both of those positions miss something. The real question is more specific and more interesting than either camp tends to engage with. Could there have been a sophisticated technological civilization on Earth before the one we know about? And if there had been, would we actually be able to detect it? By the end of tonight, you're going to see this question very differently. Not because we're going to find evidence that such a civilization existed, but because we're going to understand exactly what the evidence would look like if it had, and exactly why some of that evidence is genuinely difficult to interpret. The honest answer to this question involves some real science that most people have never thought about. Let's start there. First, let's establish the baseline. What do we actually know about human history and prehistory? The fossil record places anatomically modern humans, people biologically indistinguishable from us, at roughly 300,000 years old. The oldest confirmed specimens, found at the Jebel Irhoud site in Morocco, date to approximately 315,000 years ago. These individuals had skulls that, if cleaned and placed on a shelf in a natural history museum, you'd walk past without a second glance. They looked like us. Their brains were roughly the same size as ours, around 1,350 cubic centimeters, about the volume of a large grapefruit. But looking like us and behaving like us are different things. The behavioral modernity that we associate with civilization, things like symbolic art, complex social organization, long-distance trade in materials, ritual burial, systematic shelter construction, and the beginning of agriculture, these appear in the archaeological record at different times and in different places, gradually. The oldest undisputed cave paintings are from the Altamira and Chauvet caves in Europe, dating to around 40,000 years ago. The earliest evidence of systematic agriculture appears around 10,000 to 12,000 years ago in the Fertile Crescent, the region stretching from modern-day Iraq through Syria and into parts of Turkey and Israel. The first cities we have firm evidence for appeared around 5,000 to 6,000 years ago. Uruk, in what is now southern Iraq, is often cited as the world's first city. At its peak, around 3000 BCE, Uruk had a population of perhaps 50,000 to 80,000 people. That's roughly the population of a modest modern suburb. Writing appears at roughly the same time, around 3200 BCE, also in Mesopotamia, beginning as a system of accounting marks and gradually developing into something capable of expressing full sentences. The transition from marks to literature took about 1,000 years. This is the mainstream archaeological picture, and it's based on an enormous amount of physical evidence from excavations conducted over more than 150 years in dozens of countries by thousands of researchers with no particular incentive to agree with each other about anything. The picture has evolved significantly and will continue to evolve, but its broad strokes are not fragile. So given all of that, how seriously should we take the idea of an earlier advanced civilization? That depends on what we mean by advanced. Let's be precise. When people talk about a lost advanced civilization, they usually mean something capable of large-scale construction, organized society, writing or some equivalent record keeping, and possibly technology that influenced later cultures. Some people go further and imagine something with industrial-level technology. Some imagine something older than 10,000 years but less sophisticated than our own civilization. The specific claim matters enormously for how we evaluate it. Let's start with the geological argument, because this is the one that some actual scientists take seriously, and it doesn't get enough careful attention. In 2018, two scientists, Gavin Schmidt, director of the NASA Goddard Institute for Space Studies, and Adam Frank, an astrophysicist at the University of Rochester, published a paper in the International Journal of Astrobiology asking a specific question. Could a technologically advanced civilization have existed on Earth tens of millions of years ago? And if so, would we be able to detect it? They called this the Silurian hypothesis, a playful reference to a Doctor Who episode featuring an ancient underground civilization. But the scientific content was genuine. Their key insight was not that such a civilization existed. It was about the detectability problem. And the detectability problem turns out to be genuinely interesting. Here's the core argument. Civilization leaves physical traces. We know what our civilization's traces look like. Roads, buildings, landfill sites, underground cables, chemical pollution, nuclear fallout, specific ratios of carbon isotopes in the atmosphere, a thin layer of plastic and aluminum distributed globally. Future geologists, a million years from now, would be able to identify the current geological moment with great precision by looking for these signatures. The presence of radioactive isotopes from nuclear testing, the specific carbon isotope ratio, shift from burning fossil fuels, the global layer of microplastics, the presence of aluminum, which we refine in huge quantities, but which almost never appears in natural geological deposits in pure form. All of these would form what's called a stratigraphic marker, a thin layer in the rock record that a geologist could point to and say, this is when industrial civilization was here. But here's the thing Schmidt and Frank realized. The permanence of that stratigraphic marker decreases dramatically with time. Plastic degrades. Aluminum oxidizes and becomes indistinguishable from natural mineral deposits over millions of years. Nuclear fallout isotopes decay. The carbon isotope signal slowly blends back into the natural background. The buildings erode and the foundations get buried under sediment. The question becomes, after 50 million years, what would be left? And the honest answer is, probably not much that would be unambiguous. 50 million years is not an arbitrary number. It's relevant because if we're asking about a civilization that predates our own by enough to have been completely erased, we're talking about timescales of at least tens of millions of years. The oldest identifiable footprints of our own species are only 315,000 years old. The entire span of known human history is less than 1 million years. 50 million years is 50 times longer than our entire species has existed. Schmidt and Frank identified several geological signatures that a technological civilization might leave behind. elevated levels of a specific carbon isotope, carbon-13, in geological deposits at the time of the civilization's industrial activity, from burning what were at that time fossil fuels. Unusual concentrations of certain metals associated with mining and smelting. Specific organic chemical signatures from industrial byproducts. Possibly a thin layer of unusual mineralogy associated with large-scale construction or manufacturing. And here's what they found. Looking at the geological record, there is at least one known event, the Paleocene-Eocene thermal maximum, about 56 million years ago, that produced geochemical signatures broadly similar to what an industrial civilization might leave. The PETM was a period of rapid global warming, over thousands of years rather than the centuries of human industrial activity, associated with a massive release of carbon into the atmosphere. The cause of the PETM is still debated. Volcanic activity, methane clathrate destabilization, the release of organic carbon from seafloor sediments. Whatever caused it, the geological fingerprint looks, in some ways, similar to what an industrial civilization might leave. Now, Schmidt and Frank explicitly did not argue that the PETM was caused by an ancient civilization. They argued it illustrates the problem. If an ancient industrial civilization had existed and left a PETM-like signature in the rock record, we might not be able to distinguish it from natural processes. The geological noise is too high, the signal too degraded by time. This is a genuinely important scientific point. It's not evidence that a civilization existed. It's evidence that our ability to detect one that existed tens of millions of years ago is limited. These are very different claims, and most popular discussions confuse them. But there's a deeper layer to this. Let's talk about what happens to physical remains over geological time, because this is where the argument gets really specific. Most rocks on Earth's surface are not ancient. The vast majority of the surface rock we see was deposited or formed within the last few 100 million years. Older rocks exist, but they've typically been subjected to enormous pressures and temperatures that transformed them beyond recognition. The oldest surface rocks on Earth, the Acasta gneiss in Canada, date to about 4 billion years ago. But they don't look like the original rocks. They've been metamorphosed, cooked and squeezed under kilometres of overlying material, and what remains is a completely transformed mineral assemblage. Sedimentary rocks, which preserve fossils, cover about 75% of Earth's surface. But the sedimentary record is not uniformly preserved through time. Sedimentary basins fill up, get buried, get uplifted, get eroded. Most of the sedimentary record from before 600 million years ago has been lost. Of the record that does survive, only a tiny fraction contains fossils, because fossilization requires very specific conditions. An organism or object has to be buried quickly enough to prevent decomposition. It has to avoid being crushed or heated beyond recognition. The minerals in the surrounding sediment have to be able to infiltrate and replace the original material. And then the resulting fossil has to be uplifted back to the surface and exposed exactly when a paleontologist happens to be nearby. The probability of any given organism being fossilized is extraordinarily low. Scientists estimate that the total number of fossilized specimens of all species ever discovered represents a minuscule fraction of the total organisms that ever lived. We find about 250,000 fossil species. The total number of species that have ever existed on Earth is estimated in the billions. We have found the fossils of perhaps 1/10,000th of a percent of species that ever lived. What this means for our question is important. If an ancient civilization had left behind physical artifacts, buildings, tools, refuse, those artifacts would have had to survive the same probabilistic filter that turns most biological material into nothing. For very hard, chemically stable materials, survival over tens of millions of years might be possible in principle. But we'd need to find them. And we'd need to be looking for them in the right places, in geological formations of the right age. Here's an honest question to sit with. Do we actually do systematic searches of appropriate geological formations for anomalous artifacts? The answer is not specifically. Geologists and paleontologists are looking for other things. They're mapping rock units. They're looking for fossil fauna to date sediments. They're looking for petroleum, minerals, water. An anomalous manufactured object would likely be noticed if someone held it in their hand. But the fraction of geological material that ends up in anyone's hands is tiny. This doesn't mean artifacts are hidden and being suppressed. It means our search has not been systematic with respect to this specific question. That's a real distinction. Now let's talk about the second class of evidence people cite for ancient advanced civilizations. The archaeological anomalies. The structures that seem to require capabilities beyond what we usually attribute to ancient peoples. The most famous of these is the Great Pyramid of Giza, built as a tomb for Pharaoh Khufu around 2560 BCE, give or take a few decades. The pyramid stands about 138 meters tall today, slightly shorter than its original 146.5 meters, due to the loss of its polished limestone casing stones. Its base covers about 53,000 square meters, roughly equivalent to 7 full-sized American football fields placed side by side. It contains an estimated 2.3 million blocks of stone, each averaging about 2.5 metric tons. The heaviest blocks, the granite slabs lining the King's Chamber, weigh up to 80 metric tons each. That's the weight of about 13 adult African elephants. The precision of the construction is genuinely impressive. The base is level to within about 2.1 centimeters across its entire 230 meter width. That's a precision of roughly 1 part in 11,000. The 4 sides are aligned to true north, south, east and west to within fractions of a degree. The north face deviates from true north by about 3 minutes and 6 seconds of arc. There are 60 arc minutes in a degree and 60 arc seconds in a minute, so this deviation is about 3/60ths of a degree or 5,000ths of a degree. For comparison, a modern surveying instrument used for construction achieves precision of about 1 arc second. The ancient Egyptians were within about 186 arc seconds. What does this require? Knowledge of the stars, specifically which stars are at true north, the ability to measure angles accurately, organised labour at a massive scale, sophisticated logistics for moving and placing enormous masses of stone, administrative systems capable of coordinating thousands of workers over decades, a political and economic system capable of sustaining that effort. And here's the important thing. None of that requires technology beyond what we know ancient Egyptians had. Experimental archaeologist Mark Lehner and engineer Roger Hopkins conducted experiments in the 1990s demonstrating that teams of workers using wooden sledges, ropes, levers and sand lubrication could move multi-ton blocks at rates compatible with the construction timeline. We have ancient Egyptian papyrus documents, the Diary of Mera, the oldest known logbook, dating to roughly 2560 BCE, which describes in specific detail the transport of limestone blocks to Giza. We have workers' villages at Giza itself, excavated by Lena and Zahi Hawass, containing the bones of workers who ate well, were cared for when injured, and were buried with respect. These weren't slaves working under duress. They were skilled workers organised into teams with documented names and production quotas. The pyramid is not an anomaly that requires an advanced lost civilization. It's an achievement of organised human effort that we can trace through the archaeological record in specific detail. The evidence is there, and it tells a story of sophisticated Bronze Age Egyptian engineering, not alien intervention or lost technology. But let's be fair to the question. There are structures that are genuinely more difficult to explain in their full context. Göbekli Tepe in southeastern Turkey is the site that most legitimately challenges our conventional picture of prehistoric development. Archaeologists excavating the site, beginning in 1994 under the direction of Klaus Schmidt, found a complex of circular and rectangular enclosures containing elaborately carved stone pillars. Some pillars stand up to 5.5 meters tall, roughly the height of a two-story house, and weigh up to 10 metric tons. They're carved with sophisticated images of animals, including foxes, boars, cranes, and abstract symbols. Some pillars have three-dimensional human-like arms and hands carved into them. The date of Göbekli Tepe is the thing that makes it extraordinary. It was built approximately 11,000 to 12,000 years ago, during a period when the people living in the region were, according to the conventional model, hunter-gatherers. This predates the earliest known agriculture. It predates pottery. It predates writing by about 7,000 years. By the conventional story of human development, the people who built Göbekli Tepe should have been living in small mobile bands focused on food acquisition. They should not have had the social organisation to quarry, transport and erect multi-ton stone pillars with sophisticated artistic decoration. And yet they did. We know this not from speculation, but from direct physical evidence. The site is there. The pillars are there. The date has been confirmed through multiple independent methods. What Göbekli Tepe actually tells us is that the conventional story of human cognitive and social development needs revision. It suggests that complex symbolic thinking, organised communal effort, and the capacity for large-scale construction existed among forager societies before agriculture. In fact, some researchers now propose that sites like Göbekli Tepe might have been part of the social context that made agriculture possible, not a consequence of it. This is a major revision to our understanding of prehistory, but it's not evidence of a lost advanced civilization. It's evidence that hunter-gatherer societies were more cognitively and socially sophisticated than we assumed. That's genuinely important. It changes our picture of human prehistory in real ways. But the people who built Göbekli Tepe were humans like us, with the same cognitive hardware, finding ways to organise labour and express meaning that we didn't expect from their era. Now let's talk about a piece of evidence that does sit outside the conventional narrative in a way that requires careful handling: the Denisovans. In 2010, geneticists analysing a fingerbone fragment recovered from the Denisova cave in Siberia identified it as belonging to a previously unknown group of humans. The bone dated to roughly 50,000 years ago. The creature it belonged to was not Homo sapiens and not Neanderthal. It was something else, a third group of humans that we now call Denisovans, named after the cave where the evidence was found. Since that initial discovery, genetic analysis of ancient human DNA has revealed something quite complex. Denisovans interbred with modern humans just as Neanderthals did. People in Papua New Guinea carry roughly 4 to 6% Denisovan DNA. Tibetans carry a Denisovan gene variant that helps them cope with high altitude. Australian Aboriginal peoples carry detectable Denisovan ancestry. The Denisovans were real, they were widespread, and they're part of our genetic heritage. But here's what makes this relevant to our question. We have almost no physical remains of Denisovans beyond a finger bone, a few teeth, and a jaw fragment found in Tibet. We have no Denisovan artifacts, no Denisovan art, no Denisovan architecture, despite the fact that they were genetically distinct, widespread, and clearly capable of surviving across a huge range of environments, including high-altitude Tibet. Their physical presence in the archaeological record is nearly invisible. If Denisovans, a group that clearly existed and left genetic traces in modern humans, have left so little physical evidence that we didn't even know they existed until 2010, what does that tell us about the limits of the archaeological record for detecting ancient human groups? It tells us the record has real gaps. Not gaps that suggest a conspiracy. Gaps that reflect the genuinely poor preservation of most biological and cultural material over tens of thousands of years. This is a real point. The archaeological record is not a complete inventory of the past. It's a small and biased sample. What gets preserved depends on material properties, local conditions, and the accidents of subsequent geology. The vast majority of what ancient humans made and did vanished without trace. Does this mean an advanced ancient civilization could have existed and left no trace? This is the core question. And the answer depends entirely on what we mean by advanced. Let's think about what our own civilization would leave behind if it ended tomorrow, and all surviving humans reverted to a hunter-gatherer lifestyle. What would still be detectable in 100,000 years? Some things would survive quite well. Plastics in sedimentary environments, nuclear waste in sealed repositories, certain metals, possibly the foundations of some very large concrete structures, though concrete degrades over centuries and would be unrecognizable after tens of thousands of years. The chemical signature of hydrocarbon combustion in ice cores and sediments. The layer of artificial radionuclides from nuclear testing. What would not survive? Electronic devices would be unrecognizable within centuries. Most buildings would be piles of rubble within thousands of years. Paper and organic materials would be gone within centuries. Roads and highways would be overgrown and unrecognizable within thousands of years. The cities would exist as unusual concentrations of certain mineral types, but their forms would be unrecognizable. After 10 million years, essentially nothing that was clearly manufactured would survive, with the possible exception of nuclear waste repositories, some buried metal concentrations, the broad chemical and isotopic signatures of industrial activity in sedimentary deposits, and possibly some unusual material concentrations in geological formations. This is the honest answer to the Silurian hypothesis. A very recent civilization, within the last few million years, might leave detectable traces if we looked carefully. A civilization tens of millions of years old would leave only the subtlest of geochemical signatures, if anything. A civilization hundreds of millions of years old would leave, in all likelihood, nothing we could currently identify as artificial. Now let's talk about the deep time question from the biological side, because this introduces another important constraint. Technological civilization, as far as we know, requires a specific biological substrate. It requires a species with large brains, high social intelligence, manual dexterity, long developmental periods that allow for cultural learning, and the ability to use and create language. In our case, all of those characteristics evolved in the primate lineage over the last 60 to 65 million years. Our hands, with their opposable thumbs and fine motor control, are adapted from the grasping hands of tree-dwelling primates. Our social intelligence is built on primate social structures. Our language builds on a capacity for vocalization and social learning that has deep primate roots. Before the primates, the most cognitively sophisticated animals on Earth were probably certain dinosaurs. Some theropod dinosaurs had brain-to-body ratios comparable to modern birds. Some avian dinosaurs, the birds, show quite sophisticated cognitive abilities even today. But there's no evidence that any dinosaur species was approaching the threshold of technological civilization. The largest dinosaur brains belong to the troodonts, a group of bird-like theropods. Troodon, one of the best-known members, had a brain size of roughly 50 cubic centimeters for a body mass of about 50 kilograms. For comparison, a human has a brain of about 1,350 cubic centimeters for a body mass of about 70 kilograms. A troodon brain was about 4% of human brain volume relative to body size. Clearly not approaching the architecture needed for complex tool use and language. Some researchers have speculated about what might have happened if the end Cretaceous extinction hadn't occurred. Would theropod dinosaurs have continued to evolve larger brains and potentially develop some form of intelligence? This is a speculative question. Evolutionary trajectories are not predetermined. The conditions that drove the evolution of our intelligence were specific to the primate lineage in the post-extinction world that the asteroid created. Without that asteroid, the context for our evolution wouldn't have existed. This is relevant because it constrains when a pre-human advanced civilization could have existed. For it to have happened on Earth, it would need to have occurred after some lineage of animals evolved sufficient cognitive complexity. The earliest plausible window for that would be in the last 200 million years or so, during the age of mammals and dinosaurs. And within that window, the most plausible candidates would be late Cretaceous theropod dinosaurs or Cenozoic mammals, and there's no evidence for any of them having reached technological sophistication. But let's push this further. Let's ask the question from a different angle. What if the lost civilization wasn't from Earth at all? What if the question is really about a civilization that visited Earth and influenced early human development? This is the ancient astronaut hypothesis. And while it's a cultural phenomenon with a large popular following, the evidence for it is uniformly weak. Let's go through the main arguments. The core claim of ancient astronaut theory is that ancient human cultures couldn't have built the structures they built without outside help, and that descriptions in ancient texts of flying vehicles and strange visitors represent real encounters with extraterrestrial technology. We've already addressed the first part of this. The physical evidence from Göbekli Tepe, the Great Pyramid, Stonehenge, the Nazca Lines, Puma Punku in Bolivia, and every other site cited in this context is consistent with, and often directly supported by, evidence of ancient human ingenuity. The interpretation of ancient texts as descriptions of spacecraft requires translating ancient symbolic and metaphorical language into modern technological concepts in ways that the original authors would not have recognized. The Vedic texts, the Book of Ezekiel, the Epic of Gilgamesh, ancient Sumerian records all contain descriptions that ancient astronaut proponents interpret as technology, but they also contain descriptions of gods, monsters, miracles, and events that nobody argues reflect literal physical reality. Selecting specific passages and treating them as technical descriptions while treating other passages as metaphor is not a coherent interpretive method. But here's the genuinely interesting version of this question. Not whether aliens built the pyramids, they didn't, but whether the Earth might preserve evidence of ancient extraterrestrial visits in ways that our current searches wouldn't detect. The physicist Paul Davies and other serious scientists have raised the question of whether we should be searching for physical evidence of extraterrestrial intelligence on Earth or on the Moon, rather than looking only for radio signals from distant stars. A civilization that existed millions of years before us might have visited our solar system and left some kind of marker. The Moon's surface, which has been relatively stable for billions of years without weathering, plate tectonics, or water erosion, would preserve such a marker far better than Earth's surface. We've walked on the Moon. We have returned lunar samples. But our lunar exploration has covered only a tiny fraction of the surface and has not been conducted with the explicit goal of looking for artificial objects. This is a legitimate scientific question, not because there's evidence of such visits, but because our search has been incomplete. Several researchers, including Davies and Robert Wagner, published a paper in 2011 arguing that the Lunar Reconnaissance Orbiter's data could be examined systematically for artificial structures. This is a real scientific proposal, not a fringe claim. The argument is simply that if we want to know whether anyone has ever visited our solar system, we should look systematically rather than assume the answer is no. The honest status of this is, we haven't looked carefully enough to rule it out. That's very different from saying there's evidence for it. Let's now look at the arguments that are specific to the ocean, because a substantial fraction of lost civilization claims involve underwater sites, and some of these deserve careful attention. The Black Sea was a freshwater lake until roughly 5,000 to 7,000 years ago, when the Mediterranean broke through the Bosphorus and flooded it rapidly. The timing and nature of this flood is debated, but there's good evidence that significant flooding occurred. Geologists William Ryan and Walter Pittman proposed in 1997 that this was a catastrophic event, a rapid inundation that flooded a large freshwater basin within a period of weeks to months. Other researchers argue it was more gradual. Either way, the flooding happened, and the land that was previously above water, including coastal settlements that people may have been living in, is now under about 150 meters of water. The same logic applies globally. During the last glacial maximum, roughly 20,000 years ago, sea levels were about 120 to 130 meters lower than today. That's lower than a 40-story building. Vast areas of coastal land that were above water then are now submerged. The continental shelves of Southeast Asia, which were largely dry land, form the region called Sundaland, the land bridge between North America and Asia across the Bering Strait. The shallow banks between Indonesia and Australia, large areas around the British Isles, the Persian Gulf Basin. These regions were habitable and were presumably inhabited. Any settlements there would now be underwater, and our systematic archaeological survey of the underwater portions of continental shelves is minimal. We have mapped the deep ocean floor with radar satellites and sonar more comprehensively than we've mapped the shallow continental shelves. The shallow areas, which would be most relevant for finding submerged settlements, are actually harder to systematically survey because they require direct underwater investigation rather than satellite radar. Several intriguing structures have been reported from underwater sites around the world. The Yonaguni Monument off the coast of Japan is a formation of flat-topped rock terraces that some researchers interpret as artificial and others interpret as entirely natural. The structure sits in 5 to 25 meters of water. It was above sea level during the last glacial maximum. The feature includes what appear to be steps, a V-shaped trench, and precisely angular faces. The debate about Yonaguni illustrates a real challenge. Natural geological processes, particularly in limestone and sandstone formations, can produce flat surfaces, angular corners, and what appear to be steps through differential weathering and erosion along natural joint patterns in the rock. Distinguishing natural features from artificial ones requires detailed analysis. Geologists who have studied Yonaguni are divided. Some, including Masaki Kimura of the University of the Ryukyus, argue the structure is artificial, or at least modified by humans. Others argue it's entirely natural. The honest answer is that the question is not definitively settled. The Indian underwater site known as the Gulf of Kambat finds, announced in 2002, are another example. Sonar images of what appeared to be geometric structures at the bottom of the Gulf of Kambat, along with what were described as artifacts recovered from the site, were interpreted by some researchers as evidence of a city thousands of years older than any known civilization in the region. Subsequent scrutiny of the site has been skeptical. The sonar images are ambiguous. Some of the artifacts have been questioned. The site has not been the subject of the kind of systematic, independently verified excavation that would settle the question. The Gulf of Kambat is a notoriously murky, current-swept environment where archaeological investigation is extremely difficult. What we can say is that our systematic survey of underwater archaeological sites is genuinely incomplete. We know ancient humans lived along coastlines. We know sea levels have changed dramatically. We know that some of those coastal settlements would now be underwater. And we know that our ability to find and excavate them is limited. Whether there are significant discoveries waiting under the coastal waters is a real archaeological question. Whether those discoveries, if they exist, would constitute a lost advanced civilization is a much larger claim that the evidence doesn't currently support. Let's now talk about something that the internet discussion of lost civilizations almost never addresses: the population size constraint. Advanced civilizations don't just require cognitive capability, they require numbers. A technological civilization needs enough people to sustain the division of labour that allows specialization. Farmers to free everyone else from food production, craft specialists, administrators, engineers, priests or philosophers, military. A city is not just a large collection of people. It's an interdependent system where each part depends on all the others. Sustaining that system requires a minimum population below which the whole thing collapses. The world's human population during the proposed timeframes for most lost civilization theories was very small. The global human population at the time of Göbekli Tepe was roughly 5 to 10 million people, about the same as the current population of Switzerland. And those people were distributed across the entire world, from Africa to Asia to Europe to the Americas. A local population dense enough to support city-level organisation would have been unusual. Not impossible. Göbekli Tepe demonstrates it happened, but it constrains the scale of what was possible. If we push back further to 50,000 years ago, the global human population was probably between 1 and 2 million people. At 100,000 years ago, possibly only a few hundred thousand. At 300,000 years ago, possibly as few as a few tens of thousands. These numbers come from multiple lines of evidence: genetic diversity in modern populations, which reflects past bottlenecks; archaeological site density, which reflects population distribution; and models of carrying capacity given the technology and environments available. The combination of small populations, wide geographic distribution, and pre-agricultural food production makes a Bronze Age equivalent civilization 100,000 years ago highly improbable. Not impossible, but very improbable. For it to have happened, there would need to have been a local population dense enough to sustain urban organisation in some region, and that population would need to have developed all of the prerequisite technologies in the right order, while remaining undetectable in the genetic record of modern humans. That last point matters. Our genetic record of ancient humans is increasingly comprehensive. We've now sequenced DNA from thousands of ancient humans across dozens of thousands of years of history. We found the Denisovans this way. We found evidence of a previously unknown ghost population in West Africa from their DNA traces in modern people. We've identified migrations, bottlenecks, admixture events. The genetic record is not complete, but it's becoming a powerful tool for detecting groups that left no physical trace. A large, dense population of technologically sophisticated humans 100,000 years ago would likely show up in our genetic data. Currently, no such signal is visible. Now let's address the most careful and specific version of the argument, the one that has the highest scientific credibility. And that's the question of what happened in the Younger Dryas period. The Younger Dryas was a period of abrupt climate cooling that began about 12,900 years ago and ended about 11,700 years ago. It followed a warming trend that had been underway since the glacial maximum around 20,000 years ago. Something reversed that warming. Temperatures in the North Atlantic region dropped by as much as 10 to 15 degrees Celsius in a very short time, possibly within decades. Glaciers advanced. The landscape changed. Species went extinct. The conventional explanation involves changes in North Atlantic Ocean circulation. During deglaciation, large amounts of meltwater from retreating ice sheets would have flowed into the North Atlantic, reducing its salinity and density, potentially disrupting the thermohaline circulation, the global system of ocean currents that distributes heat around the planet. A slowdown in that circulation could have caused rapid cooling in the North Atlantic region. But in 2007, a group of researchers proposed a different hypothesis. The Younger Dryas Impact Hypothesis, or YDIH, proposes that a comet or asteroid, possibly fragmenting into multiple pieces, struck or exploded over the Northern Hemisphere around 12,900 years ago. This impact would have triggered wildfires, rapid climate change, the extinction of Pleistocene megafauna, and possibly the decline of the Clovis culture, a distinctive early Native American stone tool tradition that disappears from the record at about the same time. The initial evidence for the YDIH included a thin layer of nanodiamonds, magnetic microspherules, and unusual carbon materials found in sedimentary deposits at the Younger Dryas boundary in various sites around the world. These materials, proponents argued, were consistent with impact ejecta. The YDIH has been one of the most contested hypotheses in recent archaeology and geology. Multiple independent groups have attempted to replicate the findings with mixed results. Some groups find the proposed markers, others don't. The interpretation of the markers is disputed. Some researchers argue they're consistent with impact, others argue they have non-impact explanations. The scientific debate is ongoing and heated. What's relevant for our topic is this. If the YDIH is correct, a cosmic impact event occurred at a time when early human civilizations, such as the people who built Göbekli Tepe, were present and active in the world. Such an event could have disrupted developing societies. It could have destroyed settlements. It could have driven migrations and population collapses. This isn't evidence for a lost advanced civilization. It's a possible explanation for why the development of civilization seems to have stalled or regressed in some regions between 12,000 and 10,000 years ago, before resuming more strongly after 10,000 years ago. It's a real scientific hypothesis about a real event that may have affected real human societies. Whether it rises to the level of lost civilization depends on how sophisticated those affected societies were, and the evidence suggests they were somewhere between Göbekli Tepe complexity and early agricultural villages. Significant, important, but not a global technological civilization in the modern sense. Let's talk now about a specific researcher whose work has influenced the popular discussion of lost civilizations more than almost anyone else, Graham Hancock. Hancock is a British journalist and author whose books, including Fingerprints of the Gods, published in 1995, and America Before, published in 2019, have sold millions of copies and genuinely shifted public thinking about ancient history. His core argument is that a sophisticated maritime civilization existed before the younger Dryas impact was largely destroyed by that event and left traces in the knowledge and monuments of subsequent cultures worldwide. Hancock draws on a wide range of evidence. The sophistication of sites like Göbekli Tepe, similarities in mythology across widely separated cultures, the argument that various monuments are oriented to astronomical positions, claims about the age of the Sphinx in Egypt, the presence of what he argues are anomalous structures at various sites. The scientific response to Hancock has been largely skeptical, and it's worth understanding why on a specific evidence-by-evidence basis, rather than just dismissing him because mainstream archaeologists disagree with him. The claim about the age of the Sphinx is one of the most specific. Geologist Robert Schoch argued in the early 1990s that the weathering patterns on the body of the Sphinx were consistent with water erosion rather than wind erosion, suggesting it was built during a period when Egypt received much more rain, possibly around 5,000 to 10,000 BCE. This would make the Sphinx significantly older than the conventional date of around 2,500 BCE. The mainstream Egyptological response is that the weathering patterns can be explained by factors other than age, including salt weathering, differential hardness of the rock, and the effects of periodic flooding rather than rainfall. They also note that there is substantial physical and textual evidence connecting the Sphinx to the reign of Pharaoh Khafre around 2,500 BCE, including a stele erected between the Sphinx's paws by Pharaoh Thutmose IV that explicitly associates the monument with Khafre. The Schoch hypothesis hasn't been accepted by mainstream geology or Egyptology, but Schoch, who holds a legitimate PhD in geology from Yale, continues to defend it. The astronomical alignment arguments are similarly contested. Many ancient sites show alignments to astronomical events, particularly solstices and equinoxes. Stonehenge aligns to the midsummer sunrise. Various Egyptian temples align to specific stars at specific dates. The Pyramid of Kukulkan at Chichen Itza produces a shadow serpent effect at the equinox. Hancock and others argue that some of these alignments point to astronomical positions that existed thousands of years before the conventional dates of the structures, suggesting they preserve knowledge from an earlier era. The problem with this argument is twofold. First, ancient peoples were sophisticated astronomers who tracked celestial patterns over generations, and incorporating astronomical alignments into monumental architecture was a common and documented practice. We don't need to invoke lost knowledge to explain it. Second, celestial mechanics allows us to calculate where astronomical features were at any point in history, but the sheer number of possible astronomical alignments and the flexibility in interpreting which features at a site constitute alignments makes it relatively easy to find apparent matches to many different dates. This is a statistical problem. Without a rigorous framework for evaluating which alignments count and which don't, the analysis can produce whatever answer you're looking for. The cross-cultural mythological similarities that Hancock cites, stories of a great flood, stories of sky gods, stories of a golden age followed by catastrophe, appear in cultures worldwide and could reflect multiple different origins. Common human experiences like catastrophic local floods, the universal human tendency to create creation myths and flood narratives, possible diffusion of ideas through ancient trade and migration networks, or, as Hancock argues, transmission from a common ancient source. Among these possibilities, the evidence doesn't clearly favour any single explanation over the others. Here's what's genuinely fair to say about Hancock. He has brought legitimate archaeological sites and genuine scientific debates to a massive public audience. Göbekli Tepe genuinely does challenge some conventional assumptions about prehistory. The Younger Dryas impact hypothesis is a real scientific debate. The question of submerged archaeological sites is a real gap in our knowledge. Hancock points at real things. His interpretation of those things goes substantially further than the evidence supports. But the underlying questions are legitimate. Now let's talk about something that the mainstream scientific community takes seriously and that directly relates to the detectability problem we discussed earlier, the Anthropocene stratigraphy. Geologists have proposed that the current epoch, the era of human industrial civilization, constitutes a distinct geological period visible in the rock record. They call it the Anthropocene, the epoch of humans. The International Commission on Stratigraphy has debated when exactly to mark the beginning of the Anthropocene. One widely supported proposal places the start at 1950, when nuclear testing began distributing artificial radionuclides globally, when microplastics began accumulating in sediments, and when the carbon isotope signature from fossil fuel burning became globally detectable. The specific signatures of the Anthropocene will include a thin layer of artificial isotopes, including plutonium-239, which has a half-life of about 24,100 years, meaning it will still be detectable over 100,000 years from now as a measurable anomaly. A layer of microplastics essentially everywhere in the world where waterborne sediment accumulates. A carbon isotope anomaly in marine sediments. A spike in nitrogen and phosphorus from industrial agriculture. Increased concentrations of specific heavy metals. And a distinctive shift in the biota, the collection of living organisms visible in the fossil record, reflecting both human-caused extinctions and the spread of domesticated and invasive species globally. Schmidt and Frank's analysis looked at what fraction of this record would persist over geological timescales. The plutonium signature might survive up to 100,000 years. The carbon isotope anomaly might persist in some form for tens of millions of years. The plastic layer might persist for tens of millions of years in certain environments. The biological shift in the fossil record might persist indefinitely, since fossils can survive for hundreds of millions of years. This gives us a specific, quantitative estimate of how detectable a civilization like ours would be at different points in the geological future. A geologist 100,000 years from now would find unambiguous evidence of industrial civilization. A geologist 10 million years from now would find some evidence, a distinctive carbon isotope anomaly, possibly some unusual chemical concentrations, and a distinctive biological transition. A geologist 100 million years from now would find only the subtlest of signatures and would likely not be able to confirm they were artificial. A geologist 500 million years from now would probably find nothing. So if we're asking whether a civilization existed before 100 million years ago, we're asking a question that, honestly, the geological record probably cannot answer definitively. The record is simply not capable of preserving unambiguous artificial signatures on these timescales. The absence of evidence is not evidence of absence when the evidence would have been erased by the processes of geological time. This is a genuinely humbling conclusion. We cannot look at the current geological record and say with confidence that no industrial civilization ever existed before us. We can say the record shows no evidence of one, but the record's ability to preserve such evidence is finite and decreasing with time. For very ancient civilizations, we'd be flying blind. Now let's address the strongest piece of evidence against the lost civilization hypothesis. The evolutionary one. For a technologically advanced civilization to have existed on Earth before us, something capable of building large structures and using complex tools, there needs to have been a species capable of doing so. That species needs to have gone through a specific evolutionary trajectory: large brain, social intelligence, dexterous hands, long developmental period. In the current state of the fossil record, no such species is known. We have good fossil records for the last 65 million years of vertebrate evolution. We know the evolutionary lineages that produced the major groups. We know where they lived and when. The fossil record of primate evolution is particularly detailed because primates left dense deposits in East Africa and because paleontologists have been searching those deposits systematically for over a century. We have fossil primates going back to the earliest Cenozoic. We have a reasonably complete picture of the major evolutionary transitions. We know when each major characteristic, larger brains, reduced snout, forward-facing eyes, bipedality, enhanced manual dexterity, appeared in the lineage. And nothing in that record suggests any lineage approaching technological sophistication before the one leading to Homo sapiens. This doesn't absolutely rule out a non-primate lineage reaching technological sophistication, but it makes it very difficult to argue for a technologically sophisticated civilization during the last 65 million years without identifying what species would have constituted it and where their fossils are. For timescales longer than 65 million years, we're in dinosaur territory. And while some dinosaur lineages had larger brains than most, nothing in the dinosaurian fossil record suggests approaching the threshold for technological civilization. For timescales much longer than 65 million years, we're looking at a pre-mammalian world where the most cognitively sophisticated animals were probably less capable than modern fish. The idea of a technological civilization in that era, while not absolutely impossible, requires a cognitive leap that has no support from the evolutionary record. The combined weight of the evolutionary, geological, and genetic evidence is that no technological civilization preceded ours on Earth within the last few 100 million years. The evidence is not complete enough to say this with absolute certainty, but it is strong enough to make the hypothesis quite unlikely. Not impossible, unlikely. Let's now talk about the specific question that the Silurian hypothesis raises in a different way. Not, did a civilization precede us on Earth, but what would it mean if one had? This is where the question connects to something that's genuinely scientifically important. The Fermi paradox. If life arises commonly in the universe, and if intelligent life occasionally arises from life, and if technological civilizations are a natural outgrowth of intelligent life, then where is everyone? The universe is roughly 13.8 billion years old. Our solar system is 4.6 billion years old. There are solar systems in our galaxy that are 10 billion years old, meaning they had billions of years more time than us to develop life. If our trajectory is typical, some of those systems might have civilizations millions or billions of years ahead of us technologically, and yet we see no evidence of them. The Silurian hypothesis is relevant here because it suggests a possible solution to the Fermi paradox. If industrial civilizations arise, leave a detectable but time-limited signature in the geological record, and then either collapse or transform into something less technologically visible, then the absence of obvious signals from the universe is less mysterious. Civilizations might arise, burn brightly for a few thousand or tens of thousands of years, and then either destroy themselves or transform in ways that leave no obvious beacon. Their geological record, like ours, would fade with time. This is a sobering thought, but it's also a scientific hypothesis that can be evaluated. If many civilizations arise and collapse, we'd expect to see certain patterns in the cosmic distribution of planetary chemistry. If civilizations commonly destroy themselves, we'd expect certain types of planetary signals. These are questions that future telescopes and spectroscopic surveys might begin to address. But let's bring this back to Earth and to the specific question we started with. Is there a lost civilization in our past? The honest scientific answer is, we have no compelling evidence for one. The sites that are cited as evidence, Göbekli Tepe, the Great Pyramid, Pumapunku, the Nazca Lines, Yonaguni, all either have conventional archaeological explanations or have interpretive disputes that can be addressed without invoking unknown advanced civilizations. The geological record shows no unambiguous artificial signatures from any period before the current industrial era. The evolutionary record shows no species capable of technological civilization that preceded Homo sapiens in the last several 100 million years. The genetic record shows no large population of cognitively sophisticated humans in the deep past beyond what we've identified. At the same time, our ability to detect a civilization that ended tens of millions of years ago or more is genuinely limited. The geological record doesn't preserve a complete history. We haven't systematically surveyed underwater archaeological sites. Our genetic record of the deep past is incomplete. These are real gaps. Honest science acknowledges them. The question of whether sophisticated pre-agricultural cultures were more widespread, more organized, and more capable than conventional archaeology has assumed is genuinely open. Göbekli Tepe already suggests we've been underestimating them. Future discoveries may continue to push the date and sophistication of complex human organization earlier. That's a legitimate expectation based on the trajectory of recent discoveries. But more sophisticated than we thought and technologically advanced civilization are different claims. The evidence supports the former. It doesn't currently support the latter. Here's what's genuinely interesting about where this leaves us. The question of lost civilizations, approached carefully, is really a question about the limits of our knowledge of our own past. And those limits are real. The archaeological record is fragmentary. The geological record degrades. Our surveys are incomplete. We have been systematically underestimating the cognitive and social capabilities of our ancient ancestors. The picture we have of prehistory is not wrong in its broad outlines, but it's almost certainly wrong in many of its details and possibly in some of its larger assumptions. The last 30 years of archaeology have dramatically revised our picture of how quickly and how widely humans spread, how complex hunter-gatherer societies were, how early symbolic thinking appeared, how long ago human populations were separated and recombined. The next 30 years will likely produce further revisions. Underwater archaeology will improve. Ancient DNA analysis will extend further back in time. Remote sensing will reveal buried structures that weren't visible before. Ground-penetrating radar and LiDAR surveys are already finding sites hidden under jungle canopy and under meters of sediment. What we'll find is almost certainly not a lost, technologically advanced civilization. It's almost certainly a more complex, more geographically extensive, more socially sophisticated pre-agricultural human world than we currently know about. The real past is probably more interesting than the lost civilization hypothesis, not because ancient astronauts are a better story, but because the actual story of human cognitive and social development across hundreds of thousands of years is genuinely complex and not fully told. There's one final thread worth pulling: the question of whether we ourselves might become the lost civilization before them for some future intelligent species. If industrial civilization collapsed catastrophically within the next few centuries, and if some future intelligent species evolved from whatever survived, what would they find of us? According to Schmidt and Frank's analysis, they'd find the radionuclide layer, the carbon isotope anomaly, the plastic deposits, and the biotic transition. For the first few 100,000 years, they might find recognizable ruins. After 1 million years, they'd find unusual mineral deposits where our cities were. After 10 million years, they'd find geochemical anomalies. After 50 million years, they'd find subtle hints. After 100 million years, they'd find essentially nothing they could confidently identify as artificial. This future intelligence might debate among themselves whether those geochemical anomalies were the result of natural processes or ancient industrial activity. Some of them might argue for a lost civilization. Most would be skeptical, and they'd be having exactly the same argument we're having now. With incomplete evidence, a fragmentary geological record, and the genuine humility of knowing that absence of clear evidence is not the same as evidence of absence. What we can say with confidence from everything the geological and biological sciences have established is that the story of life on Earth is longer and stranger and more resilient than any single chapter within it. Our own chapter is extraordinarily recent. The fact that we're here asking these questions is itself the product of 4 billion years of biological complexity building on itself. Whether or not something preceded us, the fact that we've arrived at the capability to even frame the question is worth sitting with. If this raised more questions than it answered, the next video goes deeper. You can watch it here.